No one's missing, but have you ever thought, oh man?
No, absolutely not. I've never looked back.
Okay, well, some people do.
Okay. Fair enough.
Some people go back and rewatch my videos for clarification.
Fair enough.
Or if I'm gone next year on this day, I'm good.
Is there a math club?
Sure.
But sure, was it not planned until
Yeah.
I just said?
No,
There you go.
CPGs.
Oh, what are you talking about? Gotcha. Okay, so we're gonna kind of piggyback off of what we did yesterday in our activity. All right. There was really no common graphs that you had to do yesterday, right? In your homework.
Don't we have to? Common graph.
Like, did you have to graph any circles in your homework last week?
Yeah. X squared plus y squared equals 5x.
Okay, but it's when you were converting. Okay, without having to convert, let's talk about some of our graphs. Okay? So there are 3 ways to make lines.
Yeah.
Anybody tell me one?
Draw it.
Theta equals an angle. That is a line. Okay? Okay? What's another way of making a line?
Randomly having a cosecant theta next to a number.
Or what's the other option?
Secant.
Yeah. All right.
Wait a second. You said secant.
Yes, I did. If we solve for r, this would be a secant theta. If we solve for r, this would be b cosecant theta. Okay? Those would be the times we would make a line. Either with slope, with 0 slope, or no slope. Let's talk about our circles. I thought you were laughing. Oh, that's funny. Just as funny. Okay, simplest way to make a circle in polar form. R equals a number. You have the center at the 0 at the pole, and the radius is how far away you are. Okay. From yesterday, there's 2 other ways. R equals a sine theta, where a represents the diameter, or R equals a cosine theta, where once again, a represents the diameter. Okay? That will help you. If you can recognize, ooh, that's a circle with diameter 5 to the left of the pole. Ooh, there it is. Like, it will save you time having to do the calculus stuff that we do tomorrow and Friday and Monday. Yeah. I want you to draw pictures with them. Yes. Limaçons, our favorite. If you call them that, I'm not going to get upset. Okay, but these are, this is the format for a limaçon. A plus or minus B sine theta, or it could be A plus or minus B. Whatever I didn't say. What did I say?
Is this the dot one?
Yeah, that's one to
Is it that one?
Yes.
Okay, I didn't know.
I heard myself for that.
There's 4 different types of leaves. Okay? And they could be oriented 4 different ways. Majority to the right, majority up, majority to the left, majority up. Okay? Now they appear in all 4 quadrants. Yes, they appear in all 4 quadrants, but there's going to be like a majority of it one way or another. Okay? If we have cosine, what 2 major directions are we looking at? Right and left. If there's a plus in between A and B versus a minus in between A and B. Okay, if we have sine in our unison, then it's going to be
No.
up or down. Okay,
Or
so the sine, they're not going to be diagonal, that is for sure. The sine versus cosine is going to determine the direction of our unison. I guess these both are going to determine direction, right?
You can say sine cosine.
Great.
You can say sine cosine difference. You're welcome.
How's that? Symmetry versus direction. Okay, so we'll narrow it down further with that plus versus minus.
And you talk to your brother about the emails.
I did.
Why is this relevant now?
A plus B. Did you figure that out in any of your?
That just depends like how
Yeah. Ratios.
Well, the ratio of A and B would determine the type, but the sum of A and B determine how far away from the pole this is going to go. We have 4 different ratios to determine the type of limosome. We have a loop, a cardioid, a dimple, and a convex. And I'll go through how we
We're gonna do like
So I'm not super concerned about the names, but you probably need to be aware of when there's a loop and when there's not. So here's what they look like.
I think the cardioid won't be the
correct.
And we know that because A over B is, okay, that's a cardioid. A over B is 1.
Did we learn this before?
This is literally my slide from pre-calculus.
Okay.
What's that?
It's sort of like
What's a slide?
Oh.
Oh. This is when A over B is what?
At least the other one's greater than.
But
I see that. Oh,
less than 2.
that's the dimple.
Yeah, this is dimpled and this is convex.
What's the A? What's the equal to 1? What's that one?
Cardioid.
What is it called?
Top one's a loop.
That's a leap.
Loop, cardioid, dimpled, convex.
The only thing I remember is
So leap, cardioid.
Aw, that's just you.
Yes, and I am terrible at spelling the word cardioid. That's what I
Is it just cardio and void? What I did.
am.
Just did cardio.
Or would it be?
Well,
Don't overthink it, man.
I'm overthinking it.
Cardioid.
Cardio ID.
Lube.
Right.
Cardio. Yeah. It's like more than one I.
Yes, and so
All
right.
Wait, what's the last one?
Don't write this down.
What's the last one called? Lube, cardioid?
Convex.
Convex.
Loop, cardioid, dimpled, convex. And see, I always think that dimpled looks like, you know, like Pillsbury boy, like, probably kind of like, oh, do you know what I'm talking about?
Yes. Yeah.
Okay.
Of course.
Because as I was saying that, I was thinking, you don't see those connectors there.
There goes the-
Don't write this down, but this is an Archimedean spiral. Kind of cool. And this is what somebody was asking me about yesterday.
Wait, that's different than a Fibonacci spiral.
Is that in?
Yeah.
It's a side
And
of
this
the
is called, yes, a
What now?
limniscate of Bernoulli. This is how you get the two pedals.
Is this the same Bernoulli or is it a different guy from the same family?
No. It doesn't matter.
No, because
Stop.
there were multiple.
Family name means it's
I don't know if I can answer that question
He brought honor to his family.
Oh my.
Wait, was I supposed to write that?
No, I said don't write them down.
So you don't write that.
Now you write it down.
Okay.
Okay, rose curves.
How come this one doesn't get as cool as the other ones? What they found out about later?
Or maybe there was just, or maybe it's because they look like this.
But they look like daisies.
Yeah, that's they don't look like we should rename them to a better name or something.
I'm guessing that,
They were looking at different programs.
well, they were like basically calling it a flower curve, but the translation to English.
Might be kind of
You don't buy that?
We can translate the other ones, do it.
They use
Okay,
Google terms.
what does A tell us?
How big? How big?
What does N tell us?
Number of petals?
Is it always N?
No. Depends if it's odd or even.
So N if it's odd,
Right in the little too.
2N if it's even. Okay, but this is what you reminded yourself of yesterday.
Yep.
And then what's the
Cosine and sine is which axis starts on?
Correct. So a cosine. So what's the cosine of 0?
1.
1. So you will always have a pedal on the positive x-axis if you have a cosine rose curve. It will also, since it's cosine, have that horizontal symmetry. Now, the sine of 0 is 0. So when you have a rose curve with sine, it will always begin at the pole, which means your first petal will appear in the first quadrant. You will always have vertical symmetry. Sometimes you have curves that have both, and that's fine. But sine is guaranteed vertical symmetry. But your first petal will be somewhere in the first quadrant, not on the axis. Okay? So those are the big differences. Okay? What we're going to do is we're going to go through the graphs of these on some polar paper. And I have a worksheet for you to practice some more conversion and then practice some
But like,
graphing.
which one's is that cosine or sine?
The first one's cosine, the other two are sine.
But how do you know that? Because the green is symmetrical on both axes.
It's not on there.
It's not on
petals.
The pedal on the positive x-axis tells you if it's
Oh, so
cosine.
for sine it doesn't have to.
For sine, your first pedal is going to be in the first quadrant.
I can't have a petal on.
Correct. Correct. We're going to do 3 graphs together. R equals negative 5 cosine theta. Caleb, what type of graph do we have? A circle. Chris, where is the circle in relation to the pole?
To the right. The left.
Okay. So
He was
we,
looking at it upside
That's right.
It's negative sine of the
It's a
It's like,
diamond.
is it like when doing that, like we have like a negative and then the sine would be like aligns to that. It is up top.
for a circle, negative sign would mean it's below the pole.
Before, oh, then, for this, okay, I need to forget that.
Now, if I ask you for the zeros of a curve, what am I asking you to solve for? But that's a good idea.
When R equals 0.
When R equals 0, which means you're crossing the pole. Okay. So when R is 0, theta is pi over 2. So for this
What?
circle,
I didn't know that.
because I know that the cosine of pi over 2 is 0.
Why do we need to know?
What?
But there's it's negative 5. Wait,
no.
what's your about the 5? Yeah.
So what is negative 5 cosine of 0 equal to?
Negative 5.
So at an angle of 0, our coordinate is negative 5.
Yeah.
So this is where we begin our circle. We draw it, we go through the pole.
Why'd you go that way? So we're supposed to draw an arrow?
No,
Like that
no,
arrow?
no, no. There's no
Yeah,
arrow.
doesn't it go the other way?
Did I draw it?
We do.
On the exact same circle.
Yes, it would go this way. Here's our 0,
Okay.
because we're going through the pole.
So it's the origin? So
So-
the 0 is just always the origin?
Yes.
Oh, so you just have to find out where it starts and then what angle.
So there's a million places an infinite number of places that the cosine of theta equals 0.
Yeah.
But it only takes us one time around to draw our circle, so I really only care about the one time it goes through the pole, so the first time pi over 2. We could keep drawing our circle over and over and over
I'm
and
still not
over.
sure what pi over 2 is.
If I plug it in up here, r equals 0. So it's our 0. It's where we are at the pole. We are at the pole at an angle of pi over 2.
What's the benefit of using this instead of just converting it to what we used to?
Well, you tell me how you're going to convert this.
Oh, there has to be a way. We go back to the thing.
We're taking the time to do this also so that when we get to area, you're not like, how do you find the 0? Or how do you find where the pedal starts and stops? Things like that. Right? Are we good? Here's our next one. Yes.
So I think it goes halfway on the symbol. Like
Mhm.
over the angle pi to 2.
So it only takes us from 0 to pi to draw that circle. Because the cosine of pi is negative 1, so at pi you're at 5. That's where that's happening. Okay? You'll find that with our rose petals too. And a circle can be clumped in with our rose curves. If there's an odd number of petals, it's only going to take until pi to get it drawn. If there's an even number of petals, it'll take us from 0 to 2 pi to get the petals drawn. Okay. All right. Benjamin, what do we have?
Rose curve.
A rose curve. Matthew, with how many petals?
4.
4 petals. Izzy, how long are they? So, at 0, if we plug in 0, what is R?
Two.
Okay. So at 0, we're of length 2, and if there's 4 petals, we know they're going to be 90 degrees apart. Will you please walk as I draw? I want you to count the number of times I go through the pole. Are you ready?
1,
2,
2, 3, 4.
So, if we go to find zeros, how many do we need to find?
4.
Okay.
Now I have to learn.
Just draw petals and you'll be fine. So, please tell me the first 4 places in which the cosine is equal to 0.
0, pi, 2 pi, 3 pi.
You go ahead and keep that right there.
Wait.
0, pi over 2, pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Yeah.
And that is what our angle to theta equals. So the 4 times that this curve goes through the pole,
Pi over 4. 3 pi over 4. I believe 5 pi over 4. 7 pi over 4.
okay? So let's say I ask you to find the arc length of 1 petal. You could start your integral at pi over 4 and end it at 3 pi over
Oh, that's crazy.
4. We'll get there.
This weird hypothetical.
It's not going to be hypothetical.
Okay. Now, if you have a rose curve in terms of sine, you're going to start at 0, 0. So you're going to have to figure out which angle is going to give you an R value of whatever this coefficient is.
So if you're doing sine, when you started, does that count as a 0?
Uh-huh. So you're going to have an extra 0 because you're going to start and end there.
That sounds like something I remember. I think I was sitting there.
Yep. Okay, last one, and then I'll get you to your worksheet.
Was convex greater than or equal to 2? Or was it convex was greater than or equal greater than convex equals
Wait, one. Which one?
convex.
Okay, so we have a limosome. Okay, Richard, what kind?
I don't convex.
Okay, 4 over 2 is greater than or equal to 2, so we have a convex. And we are going to be symmetric about the Haley, which axis? What are we symmetric about? Horizontal or vertical? Okay, vertical. And our max R value, Anthony, will be what?
Six.
It's 4 plus 2 is 6.
Oh, you're adding.
Yep. Okay, now, for a limosome, plug in the quadrantal angles and you'll be good. So if we plug in 0, 4 minus 2 sine of 0 equals
Polar.
At pi over 2, this would equal, that's not even 4. Okay? If we plug in pi, we get 4. And if we plug in 3 pi over 2, we get 6.
Whoa. Looks like an acorn.
It does.
Oh, it's right there. Oh, but that's
I meant to take it off. I shouldn't. Okay. All right. So I am going to give you your worksheet.
So we're keeping up with
Somewhere, that's what I'm talking about.
Tomorrow we'll get to do real calculus.
It sounds a little like it's not a
No, yeah, I don't think so.
I'll post my key.
There's so many graphs.
Oh wow, there's like a lot of things.
A packet.